Dear students, let us be study today about the topic chemical bonding. In this chemical bonding, you are going to learn about what you mean by a bond, what is the root cause for chemical bonding, and what are the types of chemical bonding. And in that, basically we learn ionic bond. As we know, atoms rarely occur in the free state at ordinary temperature. Except noble gases, atoms of all other elements have a tendency to combine either with each other or with the atoms of other elements to form cluster of atoms with definite composition. The force that holds together the different atoms in a molecule is called chemical bond. In other words, chemical bond is a sort of attractive force between the two atoms which holds them together in a molecule or an ion. The root cause for chemical bonding is the tendency to acquire minimum energy to have greater stability, tendency to acquire noble gas configuration, and tendency to have greater attractive force between the atoms. To have a stable compound, the atoms obey octet rule. And let us know what is this octet rule. The tendency of the atoms to have 8 electrons in their outermost shell is known as octet rule. This rule was given in the form of theory known as electronic theory of valency given by Lewis and Kossel. According to this theory, atoms take part in bond formation to complete their octet or to acquire the electronic configuration of nearest noble gas. This can be achieved by either transfer of electrons, sharing of electrons, or donation of electrons. This octet rule is applicable for the elements present in second and third period of the periodic table. Now let us know what is this, the bond. The bond formed by transfer of one or more electrons is called ionic bond or electrovalent bond. The bond formed by sharing of one or more electrons is called covalent bond. And the bond formed by donation of a lone pair of electron from one atom to another is called coordinate bond. There is another type of bond called metallic bond found only in metals. In this case, metal ions are floating in the sea of electrons so that variable number of electrons are shared simultaneously by a variable number of atoms of the metal. Hence we say metallic bond is it is in between the two atoms, it is among the atoms. Whereas ionic bond, covalent bond and coordinate bond are present between the two atoms. All the types of bonds mentioned above are called strong bonds because the attractive force between the two atoms is very strong. We also come across weak bonds between the two atoms where bonding atoms do not lose their identity. Example, hydrogen bond and van der Waals forces of attraction. Now let us know what is this hydrogen bond is. You have already studied about this. When hydrogen atom lies between the two strong electronegative atoms like nitrogen or oxygen or fluorine, in general it is called NOF. When it is linked to one atom by covalent bond and another atom by weak force of attraction. And this weak force of attraction between the two atoms is known as hydrogen bond. So I repeat, when hydrogen atom lies between the two strong electronegative atoms like nitrogen or oxygen or fluorine, it is linked to one atom by covalent bond and another atom by weak force of attraction called hydrogen bond. The hydrogen bond here it is shown by a dotted line. There also we have two types of hydrogen bonding, intermolecular hydrogen bonding and intramolecular hydrogen bonding. So that we will deal in the subsequent classes. We also come across van der Waals interaction, which involves the interaction between the atoms or molecules having inert gas configuration. Now let us study about the Lewis dot structure for atoms and ions. So these are the very important ones. So you must able to write these dot structures, remembering that hydrogen contains one unpaired electron, helium contains two electrons, of course these two electrons are paired, lithium contains one electron, beryllium contains two electrons, boron contains three unpaired electrons, carbon contains four unpaired electrons, nitrogen contains one lone pair and three unpaired electrons, oxygen contains two paired and two unpaired electrons, fluorine three paired and one unpaired electron, and neon contains four lone pairs of electron. That's why it attains a stable gas configuration. Similarly, the sodium contains one unpaired, magnesium contains two unpaired electrons, aluminium contains three unpaired electrons, silicon contains four unpaired electrons, phosphorus contains one lone pair and three unpaired electrons, sulfur contains two lone pairs and two unpaired electrons, chlorine contains three lone pairs of electrons and one unpaired electron, argon contains four lone pairs of electrons, potassium contains one unpaired electron, and calcium contains two unpaired electrons. So these are the Lewis dot structures which you should remember. Suppose if they ask, write the dot structure for chloride ion and oxide ion. So these chloride ions takes one electron and it attains the octet structure. Similarly, oxygen also takes the two unpaired electrons and attains the octet structures. And we know the metals give electrons and non-metals accept electrons. Some elements have tendency to accept and give electrons, and these are called metalloids. In this slide, I have shown whatever I have told you now. That is the dot structures, that is Lewis dot structure for various elements and even the molecules. We have written the structure for water. So where oxygen is having two lone pairs of electrons. So this is a slide that shows once again the types of the chemical bonds, as we have already discussed about this. So this chemical bond, we have two types, as I have said, ionic bond, covalent bond, the coordinate bond, as well as the metallic bond. The weak bonds like hydrogen bond, dipole-dipole bond, van der Waals bond, London dispersion forces. The question arises why the above bonds we call it as strong bonds and why the belows are the weak bonds. On what basis the strength of the bond is determined? It is determined based on bond energy. If the bond energy is greater than 42 kilojoules per mole, then all these bonds are called stronger bonds. If the bond strength is lesser than 42 kilojoules per mole, then those bonds are called weaker bonds. Now, here this slide also shows the types of the bonds that we have. As I have said, ionic bond is formed by transfer of electrons. Covalent bond is formed by sharing of electrons. Metallic bonds have free moving electrons in the cloud. So this type of the bond is also based on electronegativity. If the electronegativity between the two atoms, if it is greater than 1.67, then ionic bond is going to be formed. If the electronegativity difference between the two atoms in a molecule is less than 1.67, then it results covalent bond. Now this is a slide that shows how exactly the ionic bond is formed, the covalent bond is formed, and what are the bond parameters, then what are the polarities of the bonds. This which you have studied, even the hydrogen bond is shown in this slide. All types of the bonds we have shown in this slide. So go through this slide, and which you have already studied this in the earlier class. So this is also the another slide showing the types of the bonds what we have studied now. Now let us study in detail about the ionic bond or electrovalent bond. The bond formed by complete transfer of one or more valence electrons from one atom to another, resulting in electrostatic force of attraction between oppositely charged ions, is called ionic bond or electrovalent bond. During the formation of ionic bond, the atom which loses electron or electrons forms cation, and the other atom which gains electron or electrons from anion forms anion. Hence, ionic bond is the electrostatic force of attraction between the cation and the anion to form ionic molecule. After the formation of ionic bond, both cation and anion attains the stable octet structure. Let us take some of the examples. Coming to the first one, formation of sodium chloride. In the formation of sodium chloride, the sodium atom contains one unpaired electrons in the outermost shell. Its electronic configuration is written as 281. Similarly, the electronic configuration of chlorine is 287 because it contains 7 electrons in the valence shell. So therefore, during the formation of sodium chloride, sodium gives its unpaired electron to the chlorine and it attains the 2,8 configuration, and Cl attains 288 configuration. That is, sodium ion attains neon configuration and chloride ion attains argon configuration. In the formation of calcium fluoride, the electronic configuration of calcium is 2882. It contains 2 electrons in the valence shell, and each electron is given to each fluorine atom. As a result, calcium attains argon configuration and fluoride ion attains neon configuration. And it should be noted that ionic bond is non-directional bond because it is a Coulombic force of attraction between the two atoms. This slide also shows the Lewis dot structures of how the ionic compounds are going to be formed. So in case of the magnesium sulfide, so magnesium contains the 2 electrons, and the sulfur contains 6 electrons. So sulfur takes the 2 electrons and forms magnesium sulfide. So similarly, we have calcium chloride. So then we have aluminium oxide. So all these formations are shown in this diagram. Now coming to the another term, electrovalency. Electrovalency is the number of electron or electrons lost or gained by an atom during the formation of ionic bond. In case of sodium, potassium, silver and hydrogen, these atoms, they give one electron, hence electrovalency in this case is +1. Magnesium, calcium, barium, etc. gives 2 electrons during the formation of ionic bond. So therefore electrovalency in these elements is +2. Similarly, fluorine, chlorine, bromine takes 1 electron. So hence its electrovalency is -1. Oxygen and sulfur takes 2 electrons. Hence its electrovalency is written as -2. Compounds having ionic bond are called ionic compounds. Ionic compounds have the various properties. Let us study about the properties of ionic compounds. Ionic compounds are very stable crystalline solids having high melting point and boiling point. They are hard and brittle. They are soluble in polar solvents like water, and they are the good conductors of electricity in both aqueous state and molten state. So etc. Like this, there are many other properties. Chemical reactions of ionic compounds are instantaneous, that is very fast. Single ionic molecule do not exist as such in the solid state. However, large number of such ionic molecules extends in all directions systematically, resulting a crystal or lattice. Lattice means arrangement of atoms in the space. The structure of the ionic crystal depends on radius ratio of the cation and the anion. Sodium chloride and cesium fluoride have cubic structure. In ionic solids, cations and anions are held together very tightly in their allotted positions by the very strong electrostatic force of attraction. Hence, very high amount of energy is required to separate the cation and anion from one another to make them free to move as in a liquid. As a result, ionic solids are quite hard. They have low volatility and they have high melting and boiling point. Here I am giving the reasons for all the properties of the ionic compounds. Ionic solids are composed of parallel layers which contain cations and anions in alternate positions, so that the opposite ions in the various parallel layers lie over each other. When a lattice external force is applied on an ionic crystal, one layer of ions slides a bit over the other layer along a plane. The sliding of the layer over the other results in that the like ions come in front of each other and hence begin to repel each other, which breaks ionic solid. Hence, ionic solids are highly brittle. Ionic solids are freely soluble in polar solvents like water, liquid ammonia, etc. because the electrostatic force of attraction holding the cations and anions together in the ionic solids is reduced by the high value of dielectric constant of the polar solvent. This makes the ions move freely and interact with solvent molecules to form solvated ions. In case of non-polar solvents like benzene, carbon tetrachloride, etc., due to their low value of dielectric constant, do not allow the ions to move freely and interact with them to form solvated ions. Hence, ionic solids are insoluble in non-polar solvents. In ionic solids, as oppositely charged ions are close to one another and similar charged ions are as away from one another as possible, ionic crystals are very stable compounds. Ionic reactions take place as a result of collision between cations and anions, giving rise to the formation of new ionic compounds. Hence, practically they are instantaneous or rapid. The example for this is when sodium chloride solution. To this, when silver nitrate solution is added, instantaneously we get white curdy precipitate of silver chloride. So, because these reactions are instantaneous reactions, very fast reactions. The another property is isomorphism. Ionic solids made up of ions with identical electronic configurations show an identity of crystalline form. This is called isomorphism. Two such pairs of isomorphous compounds are given below. One is sodium fluoride and magnesium oxide. Sodium fluoride is formed and both the ions they attains the electronic configuration of neon. Similarly, magnesium oxide, both the cation and anion attains the configuration of neon. So, both these two compounds have isomorphous with each other. They have same structure. Similarly, the calcium chloride and potassium sulfide. So, in calcium chloride, both calcium and chlorine attains the configuration of argon. Potassium sulfide, both potassium and sulfur attains the attains the configuration of argon. So, therefore, these two compounds are isomorphous with each other. This slide shows whatever we have told you about the properties of ionic compounds. So, once again we can briefly say ionic compounds are crystalline, they are hard and brittle, they have high melting and boiling point, they don't conduct electricity in the solid state, but they conduct electricity in molten or in solutions. They are often soluble in water and insoluble in non-polar solvents. They have high enthalpy of fusion and vaporization. They are the good insulators in the solid state. As the ionic bond is a non-directional, ionic compounds do not exhibit isomerism. Students, let us study up to this much in this class. And in the next class, let us study what are the factors that favors the formation of ionic compounds. Thank you.